So, like I mentioned before, all surfaces in Rhino are topologically basically a rectangle that can be deformed as much as you want. So it gives you a lot of control over the curvature of the surface, but not necessarily a lot of control over the boundary or the interior topology. So often when we're working with surfaces, we not only define the shape of the surface, but we also define its boundaries through intersections and splits. And I'm going to create another surface that's a cylinder. So I'll type in the cylinder command and make sure solid is off, so we create just a single surface. And I'll start drawing inside the surface and drag that cylinder up. So now you see we have a hollow cylinder intersecting with the surface. Now I can use the intersect commands to figure out the curve geometry where these two objects intersect. So I can select both objects and type in intersect. So that'll give me that curve that defines that intersection. I can also split one surface geometry with another one. So I can select the first surface and then type in split and select the cylinder. And that will actually split this surface into two pieces. This is a good way if I want to cut a hole in the surface, for example. Now it's important to remember that the split is just an operation that's sitting on top of the base surface geometry. So if we select this geometry and hit F10, we see all the same control points still. There's nothing about that split reflected in the control points. And in fact, if we start to edit these control points, it's going to try to figure out how to redo that split operation, but it will not necessarily line up with the original cylinder. So you have to be careful when you're starting to affect the boundary of the surface with things like splits. You can lose some of the editing functionality of the original surface. Because this split operation is sitting on top of the geometry, we can always get the base surface back by doing an untrim command. So these kind of splits are considered trims. And if we select the surface and do the untrim command, we can select the boundary where the trim occurred, and it'll get rid of that trim and give us our original surface back. And I'm just going to undo back to my two surfaces. If you want to cut a hole directly, you can also use the trim command, which will combine a split and deletion. So here I'll select the geometry I'm using to do the trimming, my cylinder, type in trim, and then I'm going to click inside that cylinder where I want to trim the other surface. So using this, you can trim any number of surfaces with this cylinder geometry. I'll just hit enter to accept the change. So if I have a hole or a boundary that I want to fill in with a surface, there's basically two options to do this. I'm going to go back to my initial surface, and the first thing I'm going to do is create a plane, typing in the A alias, create a base plane from 2 points. I'm just going to move that up so it intersects just the tip of my surface. And first I'll use this planar surface to trim my curved surface and then delete the plane. So if you have a planar hole where the boundary is completely in one plane, you can use planar surf command to create a planar surf based on that boundary. So it's going to ask you to select a set of planar curves. We'll select the boundary and hit enter. And that'll give us a nice flat surface that's been trimmed to fit into that hole. Now in other cases, such as we had with the cylinder intersection, so I'll do that again, you can see that this hole is not planar, so we can't really fit a flat surface to it. So in these cases, you can use the patch command. And patch will do the same thing as planar surf, but on curves geometry that's not necessarily planar. So I'll select that boundary curve and hit enter. And what this will do is it'll do two things. First, it'll try to approximate a surface which matches the curvature around that boundary, and then it'll automatically trim that surface with our input curve. So I'll click OK. And in most cases, the curvature will line up pretty well, so you should be able to select both surfaces and join them together into one. But you can see that this didn't necessarily maintain the same control polygon as the original surface. So this is really an approximation technique and should be used sparingly. In addition to the patch, Rhino will also allow you to create surfaces that span between two input surfaces and create a smooth transition between them. So to show you how that works, first I'll create two spheres. Just create one and then copy and paste it. I'm going to rotate this one so that the seam of the surface is away from where I want to join them. And then I'll create two planes vertically. So I'll do the A alias for the plane command, hit the vertical keyword, and then drag a vertical plane up, and then I'll just move it down a little bit and over so it intersects with that sphere. And I'll do the same thing on the other sphere. And I'll use these planes to trim the geometry of the two spheres. Make sure that the plane is completely overlapping the sphere. And then I'll hit trim, trim out those pieces, exit out of the command. I'll delete those planes. And now I have these two open edges, and I can use the blend surface command, blend SRF, to interpolate a smooth surface between these edges such that it continues the curvature of both those surfaces. So after I enter the blend surface command, I can specify those two curves. And then I can adjust the seam where the surfaces have to match, and then hit enter. And here it'll show me a preview of that surface. You can change these options to control how that curvature is maintained. Position will just create a straight loft between the two curves. The curvature will enforce the most smoothness between them. So I'll click OK. Here you can see my resulting smooth transition curve. So in addition to creating surface geometry, I can also morph geometry from one surface to another using the flow along surface command. I'll show you how to do that by flowing some geometry over this surface. So the way the flow over surface works is it creates a relationship between two different surfaces and then it morphs geometry from one to the other. So the first thing I need to do is create a flat surface in approximately the same direction and aspect ratio as the surface I want to flow geometry onto. So I want to create geometry along this surface, so I'll use the plane command to create a rectangular surface approximately the same shape and size. Then I'll create some geometry on top of it, so I'll make some closed cylinders to make sure the solid is turned on. Now I'll use the flow along surface command. It's going to ask me to select the objects I want to flow. Hit enter, and then the base surface at a corner, and then the matching corner of the target surface. You see how it's basically morphed that input geometry from the planar surface onto our curved surface. So in addition to single surface patches, Rhino can work with solid surface geometry, which is defined as a closed polysurface, which is composed of one or more joined surfaces such that there's no holes in the surface. We can start exploring solids by looking at a few primitives that are included with Rhino. So for example, we can use the sphere command to create a sphere. And you can see that the sphere is actually composed of one surface patch, but it's wrapped around itself and it joins back on itself along this one seam. We can also use the cylinder command to create a cylinder, and if we have solid yes, it'll create the cylinder with two caps at the end. And if we explode this surface, you can see it's actually composed of three individual surface patches, the two caps and the single surface around, and you can also see the seams here. We can use the box command to create a flat box, and if we explode that, we see that it's also composed of 6 joined surfaces. So if the surfaces all line up exactly on the edges, we can select all of them and type in the join command, and that'll join it back into solid. And you know it's a solid because if you click on it, the property will say closed polysurface. Alternatively, if we were missing one of these faces, for example, if we delete that face, we'll join that geometry back up, and now we have an open polysurface. So open polysurface means that there's a hole somewhere in your geometry. Now if we're trying to create closed solid geometry, but it keeps saying that we have an open surface, a good tool for figuring out where those open edges are is show edges. So if I have a polysurface selected, I type in show edges, you can click on naked edges and it'll actually show you in an outline which edges are defining open holes in your geometry. Also, if we have a hole in our geometry that can be simply filled with a planar surface, you can automate the closing of that geometry with the cap command. So if I select my geometry here and it has this open face, I can type in cap and it'll close that face off for me. Now this only works with planar holes. So for example, if I cut a circular hole from this sphere with a cylinder, so I'll create a cylinder, make sure solid is set to no, I want to create an open surface. I'll just use that cylinder to trim out a hole in that sphere. Now that hole isn't necessarily planar, so if I type in cap, it's going to say unable to cap one object, the openings did not have closed planar loops or edges. So in this case you can use a patch to repair this hole. And we can start to work with solid objects using Boolean commands. So if you have two objects, I'll use the sphere and box. We can create a new geometry by intersecting these in different ways. And the easiest way to create a Boolean, if you don't remember what the different Booleans mean, just by selecting two objects and using the Boolean two objects command, hit enter, and now if I click the left mouse button, it's going to step through all the different Booleans that are possible. So this is a union Boolean, combines two objects. An intersect Boolean shows where the objects overlap, and then the two types of subtraction Booleans. So because curved geometry is pretty well defined in Rhino, these Booleans tend to work better in Rhino than the mesh-based Booleans in 3D Studio Max. Now if I'm working with this solid geometry, you'll notice that we're not allowed to turn on control points for these polysurfaces. So control points are used to control the geometry of a single surface patch. As soon as they're joined, we're no longer able to use those control points. So if you wanted to edit this, one way is to explode it into its constituent surfaces, and then you can turn on the control point geometry. But you can see because we've created this solid from a variety of different surfaces that have different trims, the control point geometry is not necessarily useful to us anymore. So an alternative way is to work directly with the solid geometry. So I'll select all the surfaces, type in join to get my solid back. And now you can use a variety of commands to work directly on this geometry. So I can use the move edge command to select an edge and then move it. I can also use the move face command to select individual faces and move them. And this will give you a workflow of solid modeling that's similar to things you might do in SketchUp. I can also start to work with this geometry, for example, by filleting the edges or corners. So the last thing I'll show you is how to bring an image into Rhino. Because often the way we start modeling a Rhino is by finding an image of an object we like, and we want to reproduce that image through Rhino geometry. So importing images into Rhino is very straightforward. If you have an image already on your computer, so I have this image of this pavilion saved onto my desktop, you can click and drag that image directly into the Rhino viewport, and it's going to give you a set of options for how you want to import that image. And for me, the most useful is the first option, which is the picture frame. So I'll keep that selected and click OK. And what picture frame will do is it allows you to create a surface at the same aspect ratio as that image. And when you create that surface, it's going to map the image directly onto that surface as a texture map. And now you can work with this picture frame exactly how you would a surface, but that image is going to be visualized in your viewport. So this way you can bring in images of objects you like, and you can use that as a template to start to model this geometry.